Hi, my name's William Malik. I'm Vice President for Infrastructure Strategies with Trend Micro. We're here today to talk about protecting critical supply chains using ICS Incident Response. In the course of the next 30 minutes, we're going to talk about the results of a survey that we took of over 900 organizations who had suffered various kinds of cyber incidents over the past year. I'll get into the details in a second. Let me begin with sharing the screen here. So this is our subject, and here is how we are going to spend the time. I will discuss the survey results for the first 15 or so minutes of the material. We'll take a look at the findings and provide a couple of recommendations to it. If you would like to get a copy of this report, the URL at the bottom, resources.trendmicro.com/IoT survey report, will guide you there. Over the last few years, we've had some startlingly impactful attacks that have implicated hackers impacting our supply chains. In December of 2020, the SolarWinds attack, a supply chain attack, disrupted many organizations in critical roles, not just in the US. In 2021, a hacker attempted to modify the amount of lye being put into a water treatment plant. And later last year, of course, was the Colonial Pipeline attack. In this case, the organization chose to shut down the supply line rather than risk the attack spreading through their ICS environment. So let's get to the survey results. What we found at a high level was that nearly 90% of our survey respondents reported impact to their supply chain. More than half said that this impact lasted for more than 3 days, 4 days or more. And the average amount of damage caused by these attacks approached $3 million. Now, these are serious supply chain attacks. These are organizations in the manufacturing sector, the energy sector, electricity, oil, and gas, and nearly 90% of them reported that they did have some kind of attacks. Now, we did not begin by looking for people that had attacks. We began by looking for organizations that had individuals with significant IT and OT investments and surveyed them. So this result is quite startling. The magnitude and frequency of the attacks is troubling. The frequency of the attacks over the last 12 months during the survey period showed that more than 2/5 of the organizations had been hit 6 to 10 times. And altogether, nearly 3/4 of the organizations had reported disruptions 6 or more times. Across the 900 respondents, we had reports of about 7,000 disruptions. The reason it's an approximate is we did not ask people the exact number. We asked them which category they fell in. So we had a certain number that were 1 to 5 times. Anyway, the problem is large and pervasive. And where did these attacks come from? Well, in more than half of the cases, the IT side was the initial vector of the attack. That was where it hit first. In 45% of the time, the problem was seen to be in the OT side. What this means is that your response to any kind of exploitation of your cyber vulnerabilities must be comprehensive. You cannot simply rely on the fact that they won't see the OT side or they won't get to the OT side. They will. They will see both sides, and the attacks will come on both sides. One of the problems in dealing with these attacks is the process maturity of the organizations that are subject to them. In our work, we discovered that typically inside the IT organization, most teams rated themselves as being in the risk-informed, the tier 2 level of responsiveness, and only second to the partial response. Now, in the classical cyber maturity model, level 1 means you do not have an expert. Level 2 means you have an expert. Level 3 means that that expert has moved from being a superstar, peak responder, to being a mentor and an educator. And in a level 3 or higher organization, response consists of relying on comprehensive and accurate documentation. Lacking that, you are always vulnerable to the fact that your expert may not be available. You may not be able to find them. You may not know how to get in touch with them. In their absence, you will not know what to do. And you're back at square one, trying to dig out of a problem. And this level of responsiveness impacts the cost of the outage. It impacts the duration of your recovery, as we'll see in a later chart. And these have significant long-term costs on the organization. Now, as for why these organizations were moved to implement cybersecurity measures, our survey found that in 30% of the cases, and there are multiple answers possible, the reason that they wanted to deploy cybersecurity was to prevent recurrence. Oh, it happened. We got to stop it from happening again. This is not proactive. This is reactive. The second reason, second most popular cause, was because our partners, either our suppliers or the consumers of our product, that is, people on either side of us in our supply chain, said, you got to improve your cybersecurity. The third and fourth most popular reasons was because the business saw that a new technology was coming on board, cloud-based technology, 5G-based technology, and that would require them to raise their game. Well, good. That's a great reason. Below that, we see they heard about a cyber attack and they took the news to heart. They got a poor score in some kind of cybersecurity evaluation. They had a pen test and discovered that they were vulnerable, or they felt they were forced to because they had to comply with regulations in their industry. I would observe that as the scope of these attacks becomes more pervasive, that we are going to see a greater emphasis on regulations. In fact, there was an article published just recently that said we need better standards for IoT and ICS security. And I take issue with that. We don't need better standards. We've got great standards in place. IEC 64223 is fine. We have ISACs for sharing information. The problem isn't that we don't have standards. The problem is that nobody is adhering to them. And the only way that will happen is if organizations are compelled to do so because of regulations and laws, because they're required to demonstrate a certain level of competence in operating their ICS environment, or they will not be granted access to certain markets. So there will be an increase in regulation. We can count on that. But again, if you've been the victim of a cyber attack, you have the strongest motivation to make sure it doesn't happen again. So what do we see from these results overall? That the manufacturing and electric and oil and gas utility organizations frequently experience disruption in supply due to cyber attacks, and that 72% of these organizations overall had 6 or more impactful disruptions in the 12 months of the survey period. We see a significant gap in perception, ability to analyze where the problem came from. The people that responded saying they had seen an incident attack could not really say where it happened. They couldn't identify cyber attacks in the OT side, and therefore they may misunderstand them. You can't diagnose a problem that you You can't really see clearly. And why is this? Well, insufficient analysis of the cause, getting to the root cause, seeing what was the first failure that caused this to happen. Inadequate prevention of recurrence, meaning you saw something happen and you took whatever measure you felt would be most appropriate, but it turned out not to be truly effective. This is the Band-Aid theory. This is the organization that reports at their Tuesday morning weekly status meeting that they successfully repaired the firewall that had been damaged over the weekend. And then the head of the organization says, "Well, didn't you report that last week?" And they said, yeah, it took us an hour and a half last week. We're down to, 75 minutes. So we're making progress. The leader says, we are getting better at fixing a problem, but have you thought about putting some energy into figuring out why the problem happens so you don't have to fix it anymore? That's what I mean by a mature process organization. And generally, process immaturity. We rely on experts. We don't have a plan. We have a plan and it's never been tested. These are endemic problems. The cultural mismatch between what goes on in IT and what goes on in OT certainly contributes to that, and addressing the silos of information where one side knows something but doesn't have the mechanism or even the vocabulary to explain it and share it to the other side. This is troubling. So let's take a look at some of the findings. The most important point is that in order to sustain a high level of performance, the organization must continuously invest and validate the preventative measures that it puts in place. If something goes wrong, the cost of the disruption will continue to grow over time. We're looking at the gap between the incident and when the curved recovery time approaches the optimal performance level. That space, that void, while you're figuring out what happened, what its scope is, how to contain it, and then how to begin restoring operations, that's lost opportunity. That's cost to the organization. That's lost profitability. So the message here is, knowing that your disruptions will have an increase in cost over time, first thing is apply preventative measures to make sure the disruptions can't happen. These will not be perfect, but by cutting down the number of attacks that are successful, you cut down the impact of the successful ones. In order to do that more effectively, put measures in place that allow you to detect an attack and respond to it accurately. This means you need to know what the consequences of an attack are. You need to know what vulnerabilities could cascade through the system. Run a simulation. Run a desktop exercise. Depending upon your organization's culture, you may find it helpful to bring in outsiders to help with this. In fact, in some geographies, people in allied industries will work together to develop plans for incident response. This is not different from organizations in a similar industry working together to respond to a disaster. When I worked in Boston in the insurance industry, we had many insurance companies headquartered in the area. We all had significant investments in IT. And when one of us was hit by something, the others would chip in. In one case, my organization hosted a competitive organization. We gave them access to the machines that we had dedicated for training, and they ran there for a week until they could get their site back up. Test these plans, work with them, put them in place, plan for restoration, and then make sure you know how it goes. Don't make it a paper plan, make it a real living plan, test it. And as you perform the test, remember the goal of a test is not to say the plan is perfect. When you go to a doctor for a medical test, you don't want to hear the good news that they didn't find anything. You want to hear the very good news that they know exactly what the problem is and what to do about it. So when you run your incident response test, pay careful attention to the things that go wrong, because now you have the luxury of time. You can pause the clock. You can sit back and say, okay, what should we have done differently? What could we have learned earlier that would have more correctly guided our actions in recovering from this incident. And when you want to see how to respond, well, NIST has a document, Special Publication 861, which talks about how to defend. Step one is to prepare. You want to reduce your risks of infections. You want to know what your assets are. You want to know who your users are. You want to identify vulnerabilities. There's a whole list. It's the Known Exploited Vulnerability List. CISA creates and maintains it. If you have critical functioning in your IT that could be exposed to those, you can patch that now. Don't wait for the bad guys to tell you it's there. You can configure your settings properly to do this. Now, this is a particularly difficult problem in cloud, not because your people aren't good. It's because the settings for cloud are incredibly complex, 500 or more. You need to use a tool to help you make sure that you're doing the right thing. The paradox is that when you create a cloud instance, it is perfectly secure. You're the only one who can touch it. You're the only one who knows it's there. But in the process going through integration and deployment, a lot of other individuals will get their hands on that cloud instance, and they will modify settings to make it fit what they need. Some will be needed for the test and integration phase. Others will be appropriate to the deployment and production phase. You need to have some kind of test capability that will tell you how close you are to ideal and where there are any significant gaps. Invest in that. Understand your dependencies and make sure you prioritize the fixing of them, the resolution of them appropriately. You can say from an insurance perspective, well, I'll accept the risk, but there are some risks that you can accept unwillingly because there's nothing else to do. But there are other risks that you might be able to say, gee, if we do this and this, that problem goes away. Deploy the appropriate security controls. Make sure you have a comprehensive risk management program covering your third parties, that is to say, your supply chain. Take backups. And by the way, when you take a backup, make sure there's a copy that is offline and verify that you can restore from that. Because many of the ransomware attacks these days will get into your system, they'll corrupt your data, they'll identify your backups, and they'll encrypt and corrupt that data as well. So even though you have a backup, it's just as useless as the rest of the system. And as I said before, have an incident response plan and exercise that plan. That will guarantee you are optimally prepared. The extent to which you can do that will be driven by your sense of risk. And if something does happen, you want to be able to figure out what happened right away. You want to be able to contain it. You want to get rid of it, and you want to recover and get back to normal. The last page of the incident response plan always says, restore normal operating conditions. Now we'll take a look at 3 cases. These are actual customers. We've fuzzed the data a little bit. This is a case involving prevention. In this case, a company in Sweden, $1 billion revenue, 5,000 plus employees. They are moving towards Industry 4.0, and they want to secure their factory infrastructure. A lot of robots, a lot of intelligent machines. So in order to do that, they realized they had to segment their network. They did not want a flat network, which would be basically the information superhighway for malware. They wanted to make sure they could interrupt the progress of an infection. They wanted to be able to monitor this large network and all of the distributed assets efficiently, meaning that they wanted to be able to gather data, telemetry, sensing information without disrupting the flow of production. And so what they did was they centralized management through an integrated console, and they deployed the appropriate intrusion prevention technology and industrial firewall technology to secure the assets close to them at those boundaries. The goal of this is to reduce the number of incidents and implement a security framework that does not impact the production environment. Second case study. We're looking at a company in Germany, nearly 900 million euros, 22,000 employees, many, many production machines. The board said you need to put a higher level security system across the entire factory environment. They needed to secure not only the online connected production stuff, but they had a significant number of offline technology and some legacy technology. Old, in this environment, old is a relative term. An old piece of IT gear may be 8 years old. An old piece of ICS gear may be 40 years old. So you need to go through a speed match. Whichever side you come from, the IT side or the OT side, when you look at deploying technology to prevent intrusions, make sure that you're speaking the same language that your colleagues in the organization are speaking as well. They investigated and found a malware scanning tool that could handle these standalone and air-gapped devices, and they deployed that as well. The point here is that if you can't see the activity, you'll miss the incident when it happens, and you won't know what to do about it. This is a level 1 mature organization which doesn't even know that something happened until it's too late. The other thing they learned was that you can detect threats without actually deploying technology on the operational systems. You can fence it, and you can deploy stuff in the network. You can have out-of-band sensors that tell you if something is going wrong, analogous to what you do with safety systems. In the third case, U.S. engine manufacturer, 2,000 employees, 600 million revenue. They had endpoint detection technology, which gave them information about individual endpoints, but it didn't give them a comprehensive view across all of their technology. They needed to increase visibility across the threats, and so they used an XDR capability that took information not just from endpoints, but also from the mail subsystems and from various sensors deployed on the networks. And what this did was it gave them a comprehensive view, integrated through the XDR console, and analyzed to boil down the telemetry and the event notifications into a coherent story saying this seems to be what's happening, and here is the right kind of stuff to do to fix it. Now note that XDR includes the response capability, and the response capability can be automated. The most important thing here is to gather enough information to augment your automation use cases with additional new use cases to stop further attacks that attempt to follow the same TTP, that attempt to follow the same path into your organization. The success of automation depends on the richness of your use cases. So deploying sensors appropriately in layers across the organization will improve the accuracy of your analysis, help you to pinpoint, help the XDR capability itself to determine what it is that's going on, where it started, what to do about it, and where to apply the brakes so that it doesn't spread any further. Having telemetry from many different sources will improve your visibility into threat activity, which means that you will provide a more accurate and more timely response to those kinds of attacks. So what do we suggest you do in the prevention analysis area? I want you to segment your networks, protecting those vulnerable assets further. I want you to implement cybersecurity measures unobtrusively. They do not need to be deployed onto the operational technology itself. It can be alongside it. It can be upstream in the network. I want you to reduce blind spots, even for standalone and end-of-life technologies, by putting sensors into the networks and by addressing air-gap technologies. You should deploy that security without impacting target devices. You don't need to have the operational technology itself running scans for malware, doing detailed logging. You can do that upstream or offline. And make sure that your response is informed by collecting and analyzing information from multiple data sources. You want to see what's going on all over the organization. So I have a couple of recommendations to wrap up. First, silos of information are deadly. You need to be able to integrate information from classical IT and from the various tiers across your ICS environment. That includes telemetry, alerts, logs, NetFlow data on what's going on. Bring that all together into a common XDR-style console. That will allow the automation to detect things faster. It will reduce the flood of alerts into a meaningful set of symptoms with appropriate diagnosis. And again, the goal is to achieve effective response, ideally automated. What we've learned from this survey, almost 3/4 of these organizations admitted they had experienced disruption at least 6 times in the preceding 12 months. We've learned that fixing the immediate problem is not sufficient. We've seen that OT cybersecurity tends to be less mature than IT. Well, why not? We've been doing IT cybersecurity for decades. It's a relatively new concept on the OT side. The cultures and the language are not the same. Remember, the goal in IT is that data shall not be lost or altered or inadvertently disclosed. The goal in industrial control systems is preserve the underlying service and make sure things are safe. Even if they fail, they should be safe. Those are two different cultural perspectives. Those are two different sets of engineering principles that govern the activities of experts in OT versus IT. Come together, work together, figure out how you can express what needs to be said in the language the people you're talking with will understand. Improve your maturity. Conduct root cause analysis. See where the first failure took place. From a software perspective, I ran the build and test function for an IBM Poughkeepsie lab a number of years ago, and I used to joke that our development cycle had 2 phases. There was the defect injection phase, and then the defect detection phase. By doing your first failure analysis, you can push that defect injection phase very far to the left, and then you can deploy very inexpensive measures to check a defect before it gets very far into your CI/CD cycle. Process improvement is everything. The improvements in quality resulting from that are gigantic, and they apply equally well to the physical ICS side as they do to the ICT side. Adapt your security controls to cover both sides of the house. You want to protect the assets in the network without disrupting production. Take from your minds away the notion that you can reboot something to fix a problem. That is not the way it works in the physical world. And use an integrated security capability to make sure that you break through those silos for better decision-making across the board. I hope this has been helpful. My name is William Malik. I'm with Trend Micro. Please reach out to us if you have any questions, comments, or concerns. Thank you very much for your time and attention.